we're the intro Python channel in Slack. I'm going to be like putting instructions and links in there. So you'll want to join that Slack so you can get prepared. So I put a link in Slack to a zip file to download of our Git repo. The zip link will download a whole archive for you. The goal we're going to be getting to for you before we get started is being able to open up a Jupyter Notebook in this directory so that we can work in them. So if you know how to do that, like go ahead and download and unzip this and like open up a Jupyter Notebook where you're in this directory. And you'll see a couple of notebooks. If you don't know how to do that, we'll be coming around to help you. So start with getting that downloaded and unzipped.
Do you happen to know the Slack URL for the SciPy?
It's, let's see. Yep. Morning.
How's it going?
Good. Not quite yet.
Cool. Yeah, just checking. So you start right at 8.
Probably more or less, yeah.
Is there any issues with your slides? Just need to fix that.
Okay, cool, thank you. Was everyone able to install Anaconda before coming? Anybody not have Anaconda installed? That looks good. Yes, but you will need to install, like if you have Jupyter installed, you're good to go. That's all you need. Okay. The intro Python channel in Slack is where we'll be. Yeah, there's, for all of your tutorials, there was like a Slack channel. Which one? Okay. Someone not have Anaconda? Okay. So for folks that came in, if you check the Slack channel, it's intro Python on the SciPy 2018 Slack. There's a download link of a zip file of the course contents. Download that, and then we're trying to open a Jupyter Notebook in that directory. And I pasted in a screenshot into the Slack channel that shows kind of what you'll see if you're in the right place.
So for anybody who's uncomfortable with Git on the command line, you'll probably need to use Git at some point during the rest of this conference or in another tutorial. GitHub has a desktop GUI application for Mac and Windows that I posted in the Slack channel. So hopefully that can help.
And again, this is what you'll see when you've got Jupyter open in the right place. Okay, we're going to get started. My name is Matt Davis. Alyssa is our other instructor. Michael's going to be here to help us out. We'll always, whoever is not at the microphone will be here and available to help you, so feel free to raise your hand or say something in Slack. We'll be keeping an eye on it as we go. The lesson today is really to get you oriented in Python, the language. We're not going to dive deep into scientific Python or anything like NumPy, Matplotlib, Pandas. There are other tutorials for that stuff. We want to get you ready to write and understand Python. As we're going, feel free to ask questions out loud. You can raise your hand and ask the instructor something. You can, like I said, you can do it in Slack. If you just need help and you don't have a question, just try to flag one of us down, me or Alyssa or Michael. Yeah, I think you ready? All right. Any questions before we get started? Do you need the notes? Oh, you want me to do the first one? Yeah. Oh, sorry. Okay. Okay, I will get started. So you should, almost all of you, I think, are at the point of having the Jupyter Notebook opened in our lesson repo. Like this. We're going to start off in this colors.ipynb. So if you click on that, the ipynb files are IPython notebook files. So you should, hopefully we'll see something like this. We're going to be working with a library here called IPython blocks that kind of visually shows you colors in the notebook. And we're going to practice doing things like writing functions and for loops and if statements using these. So to get started, we want to kind of get oriented in the notebook. The first thing to kind of know is that there's text and code in here. So these cells are what are called markdown text. If you were to double click on one of these, it would turn into the raw text. And to execute a cell, you do shift enter, not plain enter. It goes back to rendered. This, with the word in next to it, is a Python cell. So this is Python code. We're going to import IPython blocks. So I did shift enter on that. So after you've executed a cell, a little number appears here. This is the order in which cells were executed in the notebook. So that's the first Python cell we've executed here. So it's got a number 1 next to it. Did this work for everyone who has gotten this far? This is test 1 that you can execute Python code.
What do you mean by did it work? What should it appear to be?
So a number, basically that this number 1 appeared next to it. I'm not, like when I ran it, nothing appeared in the notebook except for this number 1. So that meant it was successfully executed. Shift enter, yeah, at the same time. So the notebook has a lot of fun help features that I want you all to use a lot today. So you'll notice we imported a few things: show color, embed color picker, and colors. So now these things are available to us to use. IPython has tab completion. So I typed out show with an underscore and hit tab, and that completed for me. One of the help features is you put a question mark at the end. So you like type out one of these variable names, hit a question mark, and do shift enter. And a box pops up at the bottom of your screen with like the help text for this thing. Show color is a function. It says it shows a color in the notebook. This is how you call it. So it takes 3 arguments, and they're all going to be integers in the range 0 to 255. We're going to be working with RGB colors today, where you provide a red value, a green value, and a blue value, and those get combined to make a color. So as an example, I'm going to make something up. Got a very green color. So play with this. Another way to get to that help is if you start with the parenthesis here with your cursor in the parentheses, like you're going to call it, and you hit Shift Tab, a little floating help box shows up. And if you hit Shift Tab again while that's open, it expands and shows you essentially the same thing that happened when I did the question mark, but now it's not in your way, and you can keep typing from here, for example. If you're really excited to like find your favorite color combinations, the embed color picker function will actually, so the help text here doesn't have a lot in it, which means you can call it with no arguments. So if you're calling a function that doesn't accept any input, you put empty parenthesis there. This will actually embed a little color picker in here so that if you really need to find your favorite color, you can do that. The red, green, blue are over here. So this RGB, these are the numbers you would want to use to use your favorite color. So I want you to spend 2 or 3 minutes fiddling with this and just kind of getting used to running things in the notebook and like picking out some of your favorite colors and getting a sense for how this works. Just a moment, not too long.
Can you scroll so we can see the embed?
Yeah.
There, okay, there.
Mainly, I want verification that you can call these functions and stuff like this shows up. Yeah.
So when you said you use the show color function, can you just write red, green, and blue there as well?
If those were if those were named variables, you could. The function is going to interpret those as integers. So here I've been literally writing out integers. If we try to, you're thinking of something like this.
Yeah.
So if we try that, we get an error that red is not defined. We could fix that though. If we give those names some associated value, now we can use this because, oh, I forgot an equal sign. Now that'll work because there's an integer associated with those values that this function can work with. Does that make sense? A couple other things to note about the notebook. There are a lot of keyboard shortcuts. There's like menus up here. A lot of keyboard shortcuts that you're used to will work. Like on my Mac, I can do the same save command I used in any other program, Command S, and it will save this. You can add new cells. So like if you wanted to put a new cell kind of in between these two up here in the insert menu, you can do that. And some of these are shortcuts for like rearranging things or running things. You can like cut and paste entire cells into different orders. You can move things up and down. There's keyboard shortcuts. How do you do the keyboard shortcuts? H, okay. So I pressed H, and I got this keyboard shortcuts help menu. There are zillions of them. So you can peruse those at your leisure. But if you ever see me like magically appearing things into the notebook, I'm probably using keyboard shortcuts. And the other thing to note is that there's kind of two modes. There's like an edit mode and a command mode. When the little bar on the left side of the cell you're working on is green, you're in edit mode, and you'll see your cursor. And if it's blue, you can press escape or like click outside of the cell to get back into command mode, which is where most of the keyboard shortcuts work. There's some keyboard shortcuts work all the time, like Command S, because they're like keyed to a special key. Some of the other ones only work in command mode because they don't have a special key associated with them. And so like pressing H to get the help menu only worked when I was in command mode. Otherwise, I would be typing H's. Yeah. Okay. All right. Yeah.
On the color picker, there's an add to my color.
So this is embedding an entirely different website. So like all of that would be associated with this colorpicker.com website, not something that would be very helpful to you in the notebook here. Okay, so anyone who is not able to run a little bit of code here? Cool. Okay, so I'm gonna close this. Here in the Jupyter homepage where it lists things, you'll notice this is green now. This means that there's like a running IPython process associated with this notebook. You can shut that down if you want. If you save it, like you can reopen this later. It's a document now. All the work you did is like saved there. But if you shut down the kernel and like reopen it later, you'll have to re-execute the cells in order to kind of get back into the same state you were in. But all of that code and all of that output is saved in there. So I'm going to shut that down. And then the next one we're going to get into is this building blocks.ipynb. There's not a lot in here. We're going to be working through a series of exercises that you'll want to have up. The building blocks exercises file. I will paste this into Slack. You can also open it up as a file out of the same directory that you downloaded if you want to open it up on your computer. Oh wait, no, I'm sorry. Playing with blocks. This one. this. Okay, should look like this.
Where are you looking at?
Okay. So I'm actually going to close that one and going to playing with blocks, even though they're basically the same. Okay, so same deal here. We're going to shift enter in this first cell. When you run shift enter, it creates a new cell for you at the bottom if you're at the bottom of the notebook, or it moves your cursor down to the next cell if there's more stuff in the notebook. If you ever need to like get a new cell because you didn't get one where you wanted one for some reason, use the insert thing and it'll, wherever your cursor is. So I have this cell selected, so I could insert new cells above or below this second cell here. Okay, so the main kind of thing we're going to be working with here is something called a block grid. So you can follow along with me here, or watch. So remember the help. So we can see that the arguments this thing takes. It takes a width, a height, a fill color, block size, and some other arguments. You can read about those. Don't worry about those. The width, the height, and the fill are the main ones. And even the fill, these ones that have values next to them mean that there's a default for those. So they're optional. And if you don't provide them, this default is what you'll get. So like 0, 0, 0 is black. So if you don't provide a fill color here, you'll get black. Mm-hmm. I don't know if I can make this a little bit.
That's better. That's better.
Yeah, it comes in a little bit smaller than my main text. Mm-hmm.
How are you calling up that?
Yeah. So when I have my cursor in the parentheses here, it's Shift Tab, and then Shift Tab. This gives you kind of like the first 3 lines of the documentation. If you do Shift Tab twice, you get the full thing.
How can you scroll through a whole thing? I only see the top rows.
So here, you can't, if I do it once, if I do Shift Tab once, I get this little bit. If I do it twice, I get this big thing. So you have to do it Shift Tab, and it will hopefully open up a bigger screen, a bigger display that then is scrollable. And remember the question mark too. If you want that help to open up in a wholly, like in a whole different part of the window, you can also do that with the question mark. But then it takes up a bunch of your screen with the help. So we're going to make one of these grids and save it in a variable. I'm going to do a 5x5 grid. I'm not going to worry about the fill color. So this equal sign, the assignment, this is called an assignment. The thing on the right side of the equal sign is getting associated with the name on the left side. So now I can refer to grid, and it has what's that grid. You saw me a minute ago do numbers this way, so I could say red equals 200, and now the name red is associated with the value 200, the number 200. We'll get later into some other types of things that you can make in Python. You'll notice here that when I put a variable all by itself on a line and ran that, IPython essentially kind of echoed it back to me. And if I did like this as another example. So this is kind of a feature of IPython that when you have a variable kind of by itself on the last line of a cell, it echoes that back to you and displays it to you. So you can use that to kind of see the state of your grid. Grids also have a show method. Show. That will get it to show up too. Okay. So again, I need my notes.
How do you make a comment in it?
So comments in Python have a hash sign at the beginning. So anything after a hash sign on a line of Python code is a comment and is ignored by any kind of execution. You can put them on lines by themselves. You can put those at the end of lines, anywhere in a line. But once you have a hash mark, nothing after it is code.
Do you use the same kind of comment syntax for SQL for comment blocks with a slash asterisk?
No. The typical, so there's a couple of kind of ways of doing the block comments. For kind of inline code, the most common thing is to put a hash at the beginning of every line. And in fact, most editors and even IPython have a shortcut for that where you can like select a bunch of things and then it's, on my Mac, it's command / and it turns all of those lines into comments. There's also something called triple quotes that you can use to create really long strings. And they are used to create documentation for certain things in Python. But for the kind of comments that show up like in the middle of a function, the hash sign at the beginning of the line is the way to do that. Okay. So kind of everybody have a grid. So they've created a variable. So that's your new like vocabulary word here is variable, is saving the result of executing something and associating it with a name that you can use later. Variable. Cool. So that was exercise 1. We're going to keep going. Okay. So we're going to look at indexing. So this is getting things out of the grid. I intentionally kind of made these grids work a lot like NumPy arrays. So you're kind of learning NumPy array indexing syntax here. And it's similar to how it works too with like Python lists, which you'll see later, but these are like containers for things. So if you want to get one block out of here, we'll do grid square brackets. And this is a 2-dimensional grid, so you have to give a row and a column. Python is 0 indexed, so the first element has index 0. It's a little black square. We can change its color by assigning a new value to its RGB attributes. So block, again, I'm throwing a lot of new terminology at you, so I want to go slow and revisit it. Block is a variable that contains the result of doing this indexing on the grid. And these are indices. This is this dot RGB is an attribute on the block. So an attribute is data attached to a variable that you access with this dot syntax. So block is my variable, and then dot RGB is a piece of data associated with this. It has data in it right now, actually. So if we echo that, we see that it echoes back its color, 0, 0, 0. I can change it. An example of this, at the top here, we imported something called colors. That is a bunch of preset colors if you don't want to have to make one up on the spot every time. This is another example of IPython's tab completion, is that when you're kind of wondering what are the attributes or methods, so methods is another thing we'll get to, associated with a variable. Again, we're gonna, for tab completion, if you want to see kind of, IPython uses tab completion to show you kind of what's available. So if I hit tab here, so this was not shift tab, this was plain tab. It showed me the things that I can kind of complete off of this colors variable. And this is scrollable. And then you can click on one and it'll fill it in for you. Or you can like scroll, you can use your arrows to go through it, or you can keep typing and hit return to have it populate. So if I echo that, it's a color tuple. But I can use one of these, so I can assign a new color to this block. Execute that. So I didn't get any output from this one because I wasn't echoing a variable at the end of this. In this execution block, I was saying assign the thing on the right to the thing on the left, and that's it. But if we look at the grid now, you can see which one we changed. So we're starting with, so remember this was the block at 0, 0. So that started in the top left. So the 0th row is the top row. The 0th column is the leftmost column. And it goes 0, 1, 2, 3, 4, right? Question?
Yeah, so if you go up a couple lines
Mm-hmm.
where you define what block meant,
Mm-hmm.
so it says block is that grid index.
Mm-hmm.
I find it interesting that you define block as that index, and then you changed the attribute of block.
Mm-hmm.
Why did grid change?
Yeah. That's a good question. So the question was, when I pulled out this one block and then kind of changed its color in isolation, when I went back to the grid, that block's color had changed. Why is that? And that's a good question. In a lot of instances in Python, when you pull something out of a container, you're getting not a copy of that thing, but you're getting both the container and the variable which you assign it to. So block in this case are holding the same thing. So this variable block and the block that's inside of the grid are the same. Not just variables containing the same data, they are literally the same object in Python's memory. So when I change one, I change the other.
I guess just for completion, if you wanted to copy that index of grid
Mm-hmm.
and call it block and manipulate it without affecting grid, what would you do?
It would depend on what you had available to you with the things you're working with. Sometimes, Okay, so I didn't put a copy method on blocks, but some variable or some kind of data types that you work with may have a copy thing associated with them that allow you to copy them. In this case, we would want to write probably a little custom code that created a new block using the data from that one. Some things you don't have to worry about this because they cannot be changed. They're immutable. Blocks obviously are mutable. So immutable means cannot be changed. Mutable means can be changed. And so sometimes you don't have to worry about changing something that you pulled out of a container because it intrinsically cannot be changed. Integers are an example of that. Like you can pull an integer out of a list and add things to it without changing the integer in the list because you cannot change an integer. It can be a little bit tricky though, because if you put a variable in a list and then change the value associated with that variable, you can change the value in the list. Okay, so as an exercise, change the color of the block in the third row and fourth. Oh yeah, question.
So based on the previous question, does it work the opposite? Like if you change the index grid 0, 0, will block be changed?
Good question. So the question was, can we do this the other way around? So if I did grid 0, 0 dot RGB equals, we'll do turquoise this time, and then look at block. Yep. So in either case, those are the same, what we call object, or the same instance of a block. Trying to think of a good way to illustrate that.
So what you're really doing is you're not, when you create a variable, you're not really, you're not making a copy or creating a new variable. You're simply aliasing an existing object.
Yeah, variable, like the variable names are kind of pointers to a thing in memory. So Python has when I created this grid, Python part of creating a grid is that it creates a bunch of blocks. And when I did this assignment, Python created a new variable called block that pointed to the same block that already existed inside the grid. So it's not making a new copy of that block, it's making a new name that's associated with it. Yeah. I don't have if I had a whiteboard, I could do a good illustration of this, but like you can kind of think of it as like, oh, I do kind of have a whiteboard. How about that? I'm going to kind of change. Okay. So if we have like x equals 1, and I'll try to be loud because I'm not on the mic, and say y equals 2. 1 and 2 are just like numbers that exist in Python, and then there's x is associated with this, and y is associated with this. I think this is a good example. I don't know if I love this example.
You can do a list and make it, and then assign it to another variable and then change value in the first list.
Yeah.
You could actually demonstrate that in the notebook too.
Yeah. So let's say, we'll see lists later, but a list is a Python sequence of values. And then if I say like y equals, no, this isn't going to work either.
Well, so just do y equals x.
Y equals x, yeah. So if I do y equals x, I don't get a new list. What's happening is that both x and y point to this same list over here. And if I change y and do something like y0 equals 99, because these both point to the same list, it'll change. Changing y is the same as changing x. They're different names for the same thing.
So that's very different than other programming languages. So is there a way to just get a copy of X?
You can call copy.
Do you say Y is a copy of X or something?
Yeah.
Yeah, so there's a lot of techniques for that, so I can demonstrate that here. All right, so that's illustrating that. If you want to make a copy of a list, the usual thing is to, if we instead did, starting over, if I wrap that X in a list, that makes a new list containing the same values that were in the first one. So yeah, so this is something to keep in mind when you're working with Python, and this comes up in the context of NumPy and pandas and stuff, and Python lists and dictionaries that we'll see later, is like whether you're working with a copy or with data, or with the kind of the original thing. It comes up less often than you would think, though, in my experience. Okay, so I wanted to do an exercise, so you can practice this indexing a little bit more. Exercise 2 here is to take your grid and change the color of the block in the third row and fourth column. Question?
You called a grid earlier, and it gave you a string of numbers back. Why did it do that?
When I was doing this one?
Yeah. Like, what does the ID function do?
So the ID is like an arbitrary number associated with a Python variable. The point here is that these two things return the same arbitrary number. So kind of, again, illustrating that these are literally the same thing as far as Python is concerned. So I'll give you a minute or two to do exercise 2 here.
So when I do the tab on colors, I don't see those bunch of coloring options there. So I re-import the color picker last thing, and still doesn't show. So that's all I have. So
Without the dot, it was after the dot and saying like these are the Okay, so third row, fourth column. So to refresh my memory, my grid looks like this. I can kind of, instead of pulling out the block and then changing the color of that block variable, I can kind of string everything together and do the indexing. So third row is 0, 1, 2. Fourth column is 0, 1, 2, 3. Dot RGB equals colors dot red. So third row, fourth column. You look puzzled.
I don't even know what that's yet.
And to keep you all going, we're going to go through just a couple more exercises, and then we'll take a break. So probably at about 9:25 or so, we'll take a little break. Michael, do you remember or have heard about like the official like coffee and snack break? Is that a thing? Yeah.
I can find out.
Thanks. Have you come up with a question? Okay.
Well, okay, so here's what's happening. And I've just skipped things. I was a little behind you, I think.
Mm.
What I'm getting is just the block itself that I changed the color of,
Mm.
not the grid. So I need to change the grid name too. Like I can kind of see what, okay.
So did your grid variable get associated with the block instead of the
I think
entire grid?
maybe. I
Okay.
think so let's see.
You can always go back to the top and like copy out the grid equals block grid thing and like make a new one.
Coffee is available all day.
All day. No special snack break or anything.
I think they're gonna have snacks. I think it goes away at 10:30 or something.
Okay.
So.
Cool. Where are my extras? Okay.
When you click save, it says checkpoint created.
Uh-huh.
A special save? Like marked in some way?
I think that honestly, yeah. Okay, here it is.
I see.
Yeah. So she was asking about when you did save, it does this checkpoint, and then I don't know. It doesn't seem to keep all of them, but you can revert back to like a certain checkpoint. Okay, and then exercise 3 is to change the color of the block in the lower right corner of the grid. So that's to the max in both the row and the column. So 0, 1, 2, 3, 4. And when you're working with Python sequences, like lists, like these grids, Python has like a special syntax for indexing from the back of a thing using negative indices. So I could have done the same thing with a -1. So -1 is the last one, -2 is the second to last one, -3 is the third to last one.
So why didn't that one start at 0 if you go backwards?
Well, 0 is the first one, so we couldn't reuse that for things at the end. So it starts at -1, going backwards. This is handy when you want the like last thing or the last few things off of something without knowing how long it actually is. So you don't have to do like length math to get like the last 4 things off of a Python sequence, which is nice. Okay, and finally the last exercise 4 here is to use negative indexing to change the color of the block in the second row and first column. So you're actually going to change something near kind of the front of the grid using indexing from the back. Melt your brain. We'll take a break afterwards though.
What does it mean, essentially, if you get an error message that says list index out of range?
So let me see if I can make that happen here. So my grid goes is 5 by 5. So in positive world, it goes 0, 1, 2, 3, 4. So if I throw in some numbers bigger than 4 here, I get an error saying list index out of range because I've asked for something that is beyond the bounds of this grid. So the exercise was second row, first column. Because my grid is 5 by 5, I'm going to have negative indices, -1, -2, -3, -4, -5. Second row would be -4. And first column would be -5. Cool. Okay, any questions about kind of like we've covered like variables and indexing and attributes. That's an attribute. This is an attribute. Let's take like let's come back at 9:30 on the dot and get started. So take a break, get some coffee, etc. And we'll start talking about kind of looping over the contents of the grid and getting to operate on everything in there instead of having to pull them out one thing at a time. Cool. Probably about as big as it can go. One of y'all discovered a fun little gotcha with Python, which is that if you mess up if you mess up the attribute name, for example, and do RBG instead of RGB, you don't get an error, but also it doesn't work. This is because, and it doesn't work because you're not assigning to the expected thing, but you don't get an error because Python lets you set arbitrary attributes on objects. You can just take most any old variable in Python and like attach something to it with your own fancy name, and that's a feature. But it also can lead to bugs. So if you're like typing something out here and you're like, I'm not getting an error, but also the thing I expected is not happening, you might want to look for typos. Especially, so like if I if I typo grid, I'll get an error because like that top level variable is not defined. But if in fact, if I typo, well, let's see. And if I try to get if I try to read an attribute that hasn't been set, I'll get an error. But now I could do RBG because because that was here. Like if I did this would work now because I set that. It wouldn't have worked before I set it because it's not something that's like part of the program. I realized that I kind of forgot to introduce us beyond our names. So again, I'm Matt Davis, Alyssa Whitwell. We both work at Clover Health, which is a Medicare Advantage health insurance company. Based in San Francisco, where we work. We use Python for everything there. Alyssa and I are software engineers, though both of us have worked in data backgrounds as well. But there at Clover, we use like a lot of web applications that run in Python, data systems that run in Python, and machine learning and data analytics in Python. Everywhere it's Python. It's great. I've been coming to SciPy for close to 10 years now and always enjoy it. It's a lot of fun. You should come back if you haven't, if this is your first time. I hope it's great. Yeah. All right, I'm going to turn it over to Alyssa to start teaching you about doing loops and getting to work on all of the blocks with just a little code. Yeah.
How do you use Jupyter Notebooks?
As a software engineer, I use notebooks occasionally for prototyping, like testing things and being like, how does this work? If I do this, does it work? Because you get this very fast cycle of trying things. But I don't ship production code in notebooks. I see notebooks all the time up on the computers of our analysts and data scientists and machine learning people, though, like all the time.
So if you do a prototype in notebooks, can you just put it out as a file and use it?
I'll copy and paste it. Yeah. It's usually nothing so big that, like, it's usually a fairly small chunk of code, so I'll copy and paste it back over to a text file. Yeah.
I have a question about the RGB application.
Mm-hmm.
So I tried it, but without the RGB, and it still take the color change. So would Python understand that this is like the
So you did something like this?
yeah.
Yeah. Yeah. So this is because I wrote it this way. Essentially, like when we do the dot RGB, it's pulling out that block kind of, and then doing an assignment to the block. When we do it this way, a special method, a special like function attached to the grid is getting called with it's called set item. So it's set the value or set the variable at this index to this value, and it's doing like it's grabbing that block and assigning the color to it under the hood. I didn't have to write it that way. I could have made this not work and required you to like do the dot RGB and get out the grid, but I wrote it so that this works. Okay, Alyssa, take it away.
I'm shorter than Matt. Oh, God. Okay. My name's Alyssa Whitwell. Like Matt said, I'm a software engineer at Clover, and I used to be on our data science team. I've been in healthcare for a pretty long time, so I've worked a lot with healthcare data sets. This is not a healthcare data set. So far we've been talking about how to individually change a single block at one time, and we've been using this indexing function. But if you're using something like Python, you probably want to do this in a more systematic way because you're using a computer. So we're going to talk about for loops now. So if we wanted to actually go through and programmatically change all of the blocks in our grid, we can actually do something like for block in grid. So that's cycling through every block in the grid. And then we can set the color to something like, I had set colors. And then I picked a cool green color. So one thing you'll notice is you start with, you basically create some sort of variable that represents all of the blocks that you're going through. So I picked block, but you could pick something else. We already have our grid instantiated, so you're cycling through all of the items in your grid, which are these blocks. And you're saying, at each one that I arrive at, set the RGB values to this. And it systematically goes through and then turns all of them into this color. Yes?
So is there a syntax where you can put grid after your for statement in your line 33 such that it shows up grid with a single execute?
Are you saying that you want it to show at the end? Or?
Yeah, like so after you get your block.rgb statement, what would be the syntax to add grid after that to have it show the grid and you just hit shift enter once instead of having to go down to something type grid?
I think I can do it just here. Like, do you mean like this? Or?
Precisely like that, but when I did it, it didn't do that.
Oh, I'm sorry. Yeah, so I just did that to put it in a separate block, but you can totally put more code after a for block. One other thing to note, the Pythonic way is to have pretty indentations. So if you start the for loop, you have to have an indentation here, and then we exit the for loop, so that's why the grid is now back on the starting point of the for.
Can you clarify, just a little more detail of what terminates the for loop statement? What part of your syntax is saying it's over?
It's because I'm tabbing out. So if I don't know what will happen if I do this.
Nothing, that's what I did.
Okay, so yeah, you need the tab. There you go. Good job. Yeah, you can have certain things like, we'll talk about if statements and things like that, where you can have different conditions and they will break out, or you can return things. But yeah, this is basically all you need to do. It's implicit. So if you were to do more things here, it would happen at the block level rather than the entire grid level, because you're going through the for loop.
Before you, if it's still indented, why you did not print out 25 grid?
That's a good question. I don't know. Do you know, Matt?
It's essentially because IPython, like, remember this is a feature of IPython that it's like echoing back out that last value. When it's inside the block, IPython's not picking that up as something to show you. I wonder if you did like grid.show, it might show up in there 25 times.
Oh, there you go. Okay, so because Matt wasn't mic'd, this is an IPython feature, so IPython will print the last thing that you had in the cell, and since it was not the last thing in the cell, that's why it only printed once. Cool. Now I have a lot of amazing blocks. Okay, so let's see. So we were kind of talking about, like, what if you want to have other behaviors here, like break statements or things like that. You can actually add more conditions, and you can loop over with an if statement. So if we did, there's another thing that you can do. You can actually see it happening in real time. So when it's looping through the function, and then you see the end result, which is the fact that we changed every single block. But if you actually want to see the feature of it looping through and changing the colors, you can use this function called animate. And then we can do, I'll turn it back. So this is essentially a visual representation of the for loop. It's going through every single block and changing the colors. The animate function, I believe, is built in so it will display. So instead of us having to like show something over and over again, it's built into the function. And it's actually like refreshing every block color as you go. And when we were updating things, there was like a weird like grid thing, so it was like flashing before, so Matt fixed that. Cool. So what happens if you want to change only certain blocks but still use a for loop? In this case, let's see, we can use the row and column attributes for a grid. So if we do something like, and I have an if statement, so if the row is equal to 2, only change the color. Just kidding. Oh, it did? Okay, cool. There's a lag. Oh, okay, cool. So we're using our animate feature again, which confused me. And we're adding a second condition. So we're looping through every block. But now we want to know if the block belongs in a certain row. So it's going to cycle through each block one at a time, and it will see, is it in row 0, 1, 2, 3, 4. For the first 2 rows, for instance, it will not meet this condition, so it essentially ignores anything that's inside of the if statement. So as it's cycling through, it says, is block.row equal to 0? It's not, so ignore, and then finish that cycle, loop through the next block. For anyone that meets that condition, it will then look at this also indented condition and change the colors to the green color that I picked. I'm not sure if you did double equals yet.
No, so we haven't.
Okay. Cool. So you'll notice that these are double equal signs instead of a single equal sign. So when you have one equal sign in Python, that's assigning something to a variable. So this is what we've been doing. We've been saying the RGB values of this block will be assigned to this green color, which is the red, green, blue values. But here, we're not assigning anything. We actually want to see if this statement is true. So we're checking if the attribute row is equal to the value 2, which is different and extremely confusing.
So your double equals if and only if?
Yeah. Any other questions? Cool.
I guess I have a quick question.
Yeah.
Mine didn't work.
Oh, okay.
I double checked, and I think I have exactly what you typed. Oh, it was just slow. It did.
Oh, okay. Yeah. See, same thing.
I want the answers now.
Matt, you gotta change the refresh time to be a little bit faster. It's kind of. Also, I've been typing RBG because I like Ruth Bader Ginsburg. So I really don't want to do that. And yesterday, all I was doing was typing RBG. But you know. Cool. Let's see. So another thing that we can talk about are and statements and or statements. So if we're doing our for loop, what if I only want to have certain coordinates that meet the row and column values? I can do something if block column is 2 and, if I want to do just certain columns, I can use an or, right? Oh, that doesn't show up very well at all. Try this. That's slightly better. Can you see that? Okay. So I've used the column feature instead of the row feature, and now I've said the column can be 2 or it can be 4. So it's filling in 2 of the different columns. Similarly, you can use an and. Like this. Cool color. So in this case, it's different because it has to meet both requirements. So I want my column to be 2, and I want the row to be 0, so it only fills in one of the coordinates. Cool. Any questions? Yeah.
Is there a way to check if, so like in the example above with the columns, if you wanted to check if it was 2, 4, 8, 9, 10, 11, 12, is there a way to check if it's in like a list or something instead of repeating row statements?
Yes. I think I can do this. I think I can do this. Can I do this, Matt? Yeah? Okay.
Well, not that.
No.
Well, the 5 is.
Yeah. Got it. So like that.
Are those ands and or short circuit, like you could put an expensive comparison second and cheap comparison first?
Oh, so you're prioritizing which ones go through?
If A and B, A takes a nanosecond and B takes 20 minutes, you don't need to check B if A doesn't work, right?
Matt is saying yes.
Question. I've got an error message that says tuple object is not callable.
What did you input? It's probably something about, so this is a tuple, this is the tuple type. I guess this also makes it a tuple rather than, say, a list. I don't know if I can do it if it's a list. Yeah. So the square brackets make it a list rather than a tuple, and tuples can be named and have other things. I think a tuple is the same as a set. You had a question?
Yeah, so I got an error because I forgot to put a colon in, and then I ran it over. So how do you know if you have to put a colon in or not?
The colon is Python syntax. So when you run your code, it'll tell you that it's not syntactically correct and it will error. So if you want to put it at the end of whatever condition you're working with. So a for statement has some sort of condition because you're saying cycle through this thing, and each cycle or iteration is called some sort of variable. So then you would put the colon, and then you need some sort of condition to do the if and else if or statements as well. So you would want to state your condition and then have the colon to indicate you would go into and do some other logic. Yeah.
So your colon ends the conditional statement.
Yeah. He said your colon ends the conditional statement.
So if you're working with like a list or an array, you would type in instead of like an equal sign or 2 equal signs?
Yeah, because so if you did an equal sign, it would assign it, and I don't think you can assign a column value to a list of integers, and then the equal would be a comparator, so you'd be saying that the block column is the list itself, and the attribute can only be an integer. Cool. So you can also do additional conditions inside of an if statement. Something else. So I've said if the column is equal to 1, set it to my green color, but maybe I want other different conditions. So you can use an elif, which is an else if, basically. So if it didn't meet that condition, doesn't meet this next condition that I'm looking at. So it could be something like this, and then make up something. And then I can also add a final terminal else statement. So if the column is not 1, set it to my green value. If the column is equal to 4, set it to my magical mystery value that I've made up. Otherwise, set it to something else. I'll pick some other color. So, I don't know. So basically what I've done is I've set column 1, which is actually our second column, to my green color. If the block doesn't fit that attribute, then set it to my color, which is purple. So it's this last one here. And then all of the other columns will then get assigned to my hipster peach color that maybe doesn't show up. Any questions?
Why cannot not say just say grid.rgb equal to what color? It has to go through the itself.
Sure. So the question was, why can't we just set the value, the RGB values of the grid? And so the grid is a block grid object. So if we go back and look, there is no attribute called RGB, right? There's a fill that you can start with. But if you're doing things like specifying the color of an individual block, the RGB value attribute is an attribute of the block itself. So that's one thing. And then if you want to go in and assign parts of it, you have to do it at the block level. You can't individually change cells of the entire grid object.
Okay, so unless I call it block fill, block grid with a fill with different values, then I can set a whole thing with the color. Basically call it again.
Yeah, so
Once I have it, I cannot say fill, that fill equal to what?
we'll get to it. There are ways to do like one-liner expressions to like the entire grid or parts of the grid. We haven't got to that yet. We're doing the basics first. We'll get to that.
There are exercises for this, or we've already done it?
We'll go through most everything.
Okay. Yeah. Cool. You're back.
Sure.
Okay. I'm going to give it back to Matt now.
Thank you, Alyssa. Okay. Any more questions about like kind of that basic for loop syntax, or the if syntax? Yeah.
Just review, if you could go back to the Jupyter Notebook. Just clarify, please, the meaning of the syntax. Like you initiate with for,
Mm-hmm.
and then you start the statement. But what is the significance of the colon at the end?
So colons start blocks, essentially. Anywhere in Python where you're going to have like a block of code that has some kind of scope. So it's inside a for loop, it's inside a function, it's inside an if block. That's always started with a colon on that first line. So like starting a function, starting a for loop, starting an if, you always terminate the like definition of the for loop or the definition of the if or the definition of the function with a colon.
Does the colon on that first line after animate brackets or parentheses, does that terminate the conditional or does that initiate the
So this kind of initiates the block of code that's inside the for loop, essentially. Yeah. So you'll see it on for loops, any kind of loops, and the if statements, though there are like one-liner for and if statements that don't have the colon because they don't have a block scope. Or function definitions or class definitions are the other places that you'll see the colon. Yeah. So question here.
So when I do the question mark on the grid,
Uh-huh.
it gives me like the documentation basically. And it lists all the list of attributes that I can use on the process. But it doesn't list colon or RGB. So how do they know that all the list of attributes?
So those are not attributes of the grid, they are attributes of the blocks within the grid. So I think, I don't know if this is gonna work, but if we do grid 0, 0, no, okay. So if we do my block, no wait, that's not what I meant. I did 2 question marks. 2 question marks is also valid. 2 question marks shows you the source code in addition to the documentation. I meant 1 question mark. So the block is different than the grid. Yeah, so if you're looking at the grid, you're only looking at what's available on the entire grid. To get at what's available on an individual block, we have to look at the documentation for an individual block. Another way of getting another way of getting a list of like what's available on something is like the one is the tab completion. So here's all the stuff that's available on blocks. There's also a dir function that will like print out a bunch of stuff. It also prints out a bunch of stuff that is like implementation specific. So this is all like built-in Python things that you are not going to probably be fiddling with for a little while. So there's a lot of extra stuff if you look at this, but these are all things you can like look at or call. But they, the ones that start with underscores kind of have the leading underscores mean they're like special kind of private things, even though there's nothing saying you can't look at them or fiddle with them. Okay, so there was a good question about like changing things without kind of going through the entire grid the way we've been doing. So we've seen some examples where we've like looped through every block in the grid when we only wanted to change values in one column. So there's a couple of different ways of doing that. One, we're going to learn about the range function. So range lets you loop over a sequence of numbers, which can be useful for indexing. So this is built in. It takes a start, it has kind of 2 forms. One where it only has a stop value, in which case it starts from 0 and counts up to, the stop is exclusive because Python is 0 index. So if you do 0, so if you do range 3, you'll get 0, 1, 2. And then you can also optionally, there's another form where you can specify a start, a stop, and a step. So if you want to like start at 12 and count by 14s, like you can set that up. The way we want to use this is, okay, so I'm gonna make a new grid that's a little bit bigger than the one we had. And then I want to loop over the like width of the grid. So I'm going to change up this a little bit and say, see. If I really wanted to be, I think this will work. So here, so before when we did 4 blocking grid, we would go through each, like we would get the first block and then the second block and then the third block. Here we're gonna get numbers in I, so we'll get 0, 1, 2, 3. And now to do operations, we have to use this number in our indexing, right? So we're not getting blocks, we're gonna work on the grid. So this is, so if we wanted to change like the color of all of the blocks in the, I'm looping over the width, so let's change, I don't know, the third row. We don't, if you want to have the, well, let's see, show this, we'll see if it worked. Yeah, all right. So here we only looped over 20 things instead of looping over all 400 blocks in this grid. If you want to animate these, so we don't have that handy animate method anymore. If you want that, there's, I'm going to change the parameters of this a little bit. But if you throw a grid.flash in there, I think it will, okay, I didn't fix the horrible flickering in the flash. Sorry about that. And then if you use flash, it's nice to put the grid at the end because the flash removes it at the end. But that would work. Okay, so there's an exercise 10 to kind of use this logic with range to change, this suggests changing the color of the blocks in the 3rd, 10th, and 18th rows. You can pick different rows if you want, but practice a little bit with the range. So more or less what I had shown already. So here I typed out the different rows I want to change, like one at a time. Before we would have used an if block to say like if block dot row equals 2, turn it this color. If block dot row equals 9, turn it this other color. Here we can do it all at a go, and we'll see that the I'm sorry about that, that it's like each time through it's changing every column. Or yeah, every column. So range comes up. It's a very common one. We can do combine these. Like we can do a nested one if we want to change like a 2D-dimensional section of the grid. So we're gonna do one range over like a span of columns and another range over a span of rows. So I'm gonna do like I'm actually gonna use better variable names now for a row in range. Let's say 9 to 15. And then for a col in range. So one level of indentation for that outer loop, another level of indentation for that inner loop. So we end up over 8 spaces over here.
Can you animate that loop?
Yeah, so if you did the grid.flash here, you would get the animation. So if I change the color to something else. You know what, I would have to rerun everything. I said I was gonna fix this, but I would have to rerun the whole notebook to re-import it.
So doing 2 lines of for loops is kind of like saying for row in range and for column in range?
Yeah. So the inner one is getting cycled like a full cycle through for every one cycle of this, right? So like this starts out with 9, and then while row is 9, we do column 5, 6, 7, 8, 9, 10, 11, and then it goes back out, and this executes 6 times. And then it goes back out to here, and row becomes 10, and then this comes in here and cycles through 6 times.
Does it make more sense to do that, or could you put that in one line?
You can put it in one line. Not with the word and, though good instinct, but and is reserved for logical combinations of things. There's a function called zip that is useful for this kind of thing. So we can do for row col in zip, and then we put in both ranges here. I'm gonna make up some new ones. Actually, this won't work because it will pair them. We want the product of these, which you can also get, but we have to import something. This is a good opportunity to talk a little bit about the Python standard library. Way up here at the top, we imported some stuff from IPython blocks. IPython blocks is a file here in this repository, like it's a file we could look at. It's right there. We can open it, in fact, and look at it. So that's how you're getting this code, is because this file is right here, and when we do from IPython blocks or import IPython blocks, Python is reading this file and interpreting it and like loading all of the stuff for you. There's a lot of other stuff you can import from Python standard library. The README of the repo has links to a bunch of this stuff. This global module index is a list of all of the modules that are built into Python. There are a few. So like a lot of functionality that ships with Python is not exposed like the instant you are working in Python. It's requires you to import it. And this is to like kind of namespace things to make sure that like it's not a huge volume of stuff that gets imported with names colliding and stuff when you first start at Python. It allows you to pull in only what you need and kind of pick and choose. The thing I'm thinking of for your question is in the itertools module, which is definitely in my top 5 favorite Python modules built into Python. And the product function here allows you to kind of on one line put together several different things and simulate a nested loop the way we did. So we could do that. This as thing says like import this, but give it this name. So that I don't have to type out itertools. And then if we do for row col in it.product, and then we do our ranges. So rows near the top, columns near the mid to right. That is so annoying. Okay. Yeah, good question. Cool. So any more questions about range? Yeah.
Can you go back up? I typed something wrong. Yeah, there. I guess I have a question. So I guess I typed a square bracket instead of a round in range.
Mm-hmm. Yeah. So there are you'll have noticed probably that sometimes we're using square brackets, sometimes we're using parentheses. And they mean different things to Python. Parentheses are calling something, which means, and they kind of actually both call something under the hood. But I think of the parentheses as like, take these inputs and like go execute your code and then come back. The square brackets have a specific connotation related to indexing, pulling things out of a container or putting things into a container. Did that help?
Yeah.
Okay.
Explain that again, please, just 'cause that was the same question I was interested in is, and I mean, there's gonna be exceptions and there's nuance and everything, but
Yeah.
in general, how does one know when parentheses are called for versus brackets?
So I think the way I think of maybe the square brackets as a special case of where you have a variable, in our case grid, that is a container for other things, and you want to get things out of that container or put things into that container. Square brackets are probably how you're going to do that.
So parentheses are inputs or outputs, but square brackets are locations within something else.
Yeah, you could think of it that way. So like both of them kind of mean, I keep wanting to say like parenthesis means like go do something, but they both do something. So I kind of think of the square brackets as like the subset of some things that is like getting things out of or into containers.
It's like calling a function, except you haven't talked about functions yet, so.
Yeah. Question?
So when you say container, do you mean like container, like a Docker container? Or is it
No.
anything?
No, so I mean a Python data type that holds other things.
Okay.
Yeah, so in our case, grids hold blocks. We talked about a little bit about lists. Lists hold other things. We'll talk about dictionaries. Alyssa showed you tuples, which is another kind of container. Yeah, variables that hold other variables or other data. Awesome questions, you all. Thank you. Okay, so last thing, we've kind of had you working like in the weeds to kind of get you to look at all of the syntax of Python. We're finally going to get to the like magical way of doing things, which is how you would do it in NumPy and Pandas, where like you put it all on one line and say you select data and do assignments all in one line with slicing. Slicing is a syntax for selecting more than one thing, but using the same, a very similar looking syntax as we have used to select one thing. So here, right, we're selecting one thing, one item, one row, one column. You can also select out more than one thing. So I'm trying to look for an interesting subset of this grid to grab. So it'll look, say, square brackets. Now we want a range of rows. So I'm going to grab like 5 to 10. So separated by a colon. So the start and the end. As with range, the end is exclusive. So it starts with 5, but it will end with 9.
And is that 0 indexed? Or like
It's
is that 5 really 5 or is it 6?
It's the 6th item in the, yep. And then over here, maybe we'll do like 0 to 6. Okay, so that was, I got my rows and columns backwards. So we got like this slice right here.
Because we did say grid at the beginning with that.
Mm-hmm.
That confused me that I didn't have to repeat grid at the end of things together.
Yeah. So this kind of gives a new grid that is a view on the original grid. And because it's the last thing in the cell at the kind of top level of the cell, IPython echoes it for you. So this works for both assignment and for retrieving. So I can take this same thing and change the colors here. Or, sorry. Magenta, that's a good one. Okay. And here I will need to echo back like the grid. There's some special syntax for like everything along one of the dimensions. So if you wanted to change all of the columns in a particular row or a set of rows, so we could do and negative indices work in slices too. So we could do like grid. Okay, so let's take a close look at this. So I've omitted some of the numbers here. So -3 : is going to mean from the third to last item all the way to the end. And then a colon with no numbers means everything. So like from the first row, or from the first column to the last column, all the way across. So it turned the last 3 rows aquamarine. So again, like this kind of slicing is like integral to NumPy. Like working with NumPy arrays, like you do so much slicing. And Pandas too has slicing, but it has, because it works with non-positional indexes, a lot of the time slicing works a little bit differently, but there are similar things. I should extend IPython blocks to have like Boolean fancy indexing.
So if we wanted to write code that would color everything here, it would be more efficient to use this one line of code versus looping through everything. Is that correct?
So the reason I'm hesitating is that it depends what happens under the hood. So when you do this when we do this expression it's more efficient in terms of the number of lines of code you have to write. In IPython blocks, under the hood, it's doing a for loop. Essentially the same for loop you would have written. However, in NumPy, that operation usually is not executed in Python, but is executed in C, which makes it a lot faster. So that's why a lot of times in NumPy, you're encouraged to use slicing and other forms of fancy indexing, because it allows NumPy to handle the loops at its discretion, usually in C instead of in Python, which is where the performance improvements come from.
If I want 2 separate rows, let's say row 2 and 9, what is the right syntax to put it into the slicing?
If you wanted 2 and 9.
Yeah, 2 and 9 and then every column. I just don't get the syntax right. It doesn't want parentheses operators.
Okay. So doing 2 different rows that are not like adjacent to each other is tricky. I would do that on 2 different lines, probably. There is a syntax with slicing where you can give it slicing works almost exactly like range, where you can give it a start, a stop, and a step size. So I might be able to change like every 3rd row. I don't know if this is going to work. It did. Okay. So if you can, but you need some kind of pattern with range and with slicing. You need to be able to say it's going to be like this one, like it's this range, like it's these adjacent rows, or it's like start, a stop, and doing every 2nd or every 3rd one. If you have just like an arbitrary set of ones, of rows that you want to change, not with IPython blocks. Like IPython blocks is not going to support that. NumPy does support some feature set like that, yeah. Yeah. So with NumPy, I think, I don't know exactly off the top of my head how to do it, but you can kind of do something like this.
Yes, that's exactly what I was trying to do.
Yeah. So this is not implemented in IPython blocks. Yeah. Oops. Okay. Does everybody feel like they've got sufficiently to play with question.
Can you explain again the two agreed semicolons?
Yeah. Yeah. So here, let me do another example of this. So that's kind of as with range, where you can have like a start, a stop, and a step. With slices, you can also do that. So you can do like, So this means start at 4, stop at 11, go in every other row. If I want to say start at the beginning and go all the way to the end, I take out the start and the stop, but leave the step. Okay. So if everyone feels like they have gotten to play with range and slices sufficiently, I think we could take a quick break and come back around 10:35, and we'll keep learning. Was there a question?
Punching in negative indices broke it. So you had to put in the negative step.
Negative indices and slicing is a mind-bending exercise, but it is possible. Just go have fun with that. Yeah. All right, quick break. 10:35. We'll get started again. So we've been through for loops and if statements, and kind of the reason, even though we kind of ended up in a place where you didn't end up needing to use them to do a lot of the things that we were having you do with them. The reason we have you work with those so much is that they're like really foundational to getting anything done in programming. Computers are were literally invented to do repetitive things. That's loops. And then your if blocks allow you to do different things depending on different values in the data. So like the for loops, and there's more than one kind of loop. For loop is one kind. Python also has while loops. Loops and the if blocks, the conditionals, is like the core to getting things done in computing. So we kind of wanted to get you down in the weeds for a while. Another really important thing is reusing code, is getting to write like a block of code that you can call repeatedly with different inputs and say, do the thing you're designed to do it on this one, do it on this one, do it on this one, without having to like manually write all that out. And that's functions. So we're gonna start talking about functions now. As an example of a function, like you might encode a temperature conversion function, Fahrenheit to Celsius, and then instead of every time you want to do a temperature conversion, instead of having to type out this, instead of having to type out the math, you call the function. So it's going to be like 90 something today. So let's see what that is in Celsius. 33. See what it is. Probably back in the Bay Area, 20 something. Right. So instead of typing out this like kind of math thing, we can replace that with a function that has a really useful, easy to remember name. Kind of looking at the syntax of the function, it starts with this def keyword. That's important. The name of the function, then parenthesis. You'll put the parentheses there even if the function doesn't take any arguments. It doesn't have to. If it does take arguments, you put them in here. And then you end the whole thing with a colon that indicates you're starting the block of code that is inside the function. This is a short function. Functions can have as many lines as you like. as with the for loops and if blocks, the indentation matters here. So if I was to put something down here, that would not be considered inside the function because it's back out an indentation level. The return keyword is how you get things back out of a function. And that's how, that's how these are showing up here. We could capture these too and say, and now we have that in a variable that we could reuse later. But this return keyword is how we do that. I'm going to turn off. Cool. And you can put code in here. You can create variables. I'll get back to you. So if we wanted to break this out into like different things, we could do like factor equals 5/9, and then replace this with the factor, and so on. Like my point kind of is like, this is arbitrary code. You can write whatever code you want here inside the function. Be mindful of the indentation though, or you can kind of accidentally end up back outside your function. Question?
So where in Jupyter your functions are saved? Sometimes you have to write the function, you save it in a code, and you put it either in the same folder or do you put it eventually?
So the question was like, where is the function saved? In this example, this function is only available within this notebook after you've executed the cell in which it's defined. There are when you've written code that you want to reuse in multiple notebooks, you kind of have to take a different strategy, put it out in a Python file that then you can import, kind of in the same way like the IPython blocks thing that we're importing here. And it can get, the ways in which you kind of share that code across different places can be vary a little bit, like by type of system. Usually this is why you end up writing a library. Like you figure out how to package and install your code using Python's like distribution methods. That's a whole nother topic. One thing I did for years, kind of my first software job, was like I had one directory that contained all of my code in like dozens of Python files, and I set an environment variable called Python path on my computer that pointed to that directory, and then I could import any of those files from anywhere on my computer. So that's one option. That's kind of like the easiest option, but then you end up with dozens of Python files all in one directory, and it gets kind of messy. It was fun.
Well, I was just wondering, so if we have it here, how can we save it? Can we save it as a Python code here or no? We'll have to use another like.
You can like export these as Python files, but they're pretty messy because like all of this stuff is up at the top level of the file and would get executed when you imported that file. Usually you want to be a bit more deliberate in your organization than that. So as I said earlier, I usually end up like copying and pasting stuff out into other files. The other question?
Yeah, what if you want the function to return more than one structure?
Absolutely. So depending on what the function does, you might just return some kind of container, like a list or a dictionary that we'll get to. But you can also do stuff like this. What this is doing is returning a tuple of those values. But Python has kind of some nifty unpacking that it does so that this syntax works.
In your expression for where you will return 1, 2, 3, 4, instead of those integers, can those be separate expressions?
What do you mean by expressions?
Well, you had a Celsius, or Fahrenheit and Celsius.
Yeah.
So could you have just drawn up a bunch of mathematical expressions?
Yeah, absolutely. You could, you know, do this. Yeah. The parentheses here like allow you to organize things in Python. So like anything inside this like outer parenthesis is like going to get reduced to one thing as Python executes. So if you make a list of these and have parentheses around them to help organize them, like Python will reduce all of that in the way you would expect. Good question.
You could write multiple functions within that and choose which ones you want to print in the return statement. Like you could just select factor, and then you could also have something else, for example, and also have that output.
Mm-hmm. Yeah. So if you could replace this with, you know, if you had a stats function where you calculated like the standard deviation, the mean, and mode, like you could calculate all of those and return all of them at the end. Yeah.
So could you have a tuple as an input then, like use a for statement inside your function and for I in?
Your inputs can be anything. This is the first time you're seeing the print function. So if I try to call this with only one thing, it errors because this for loop doesn't work. I have to put it inside some kind of sequence like a list. So you can have a list with one thing in it. That works. Yeah. So this is going to be a little bit of a longer exercise, but I want you to write a function that takes a grid as input and returns a new grid that inverts the colors in the original grid. So to think about inverting a color, so like black becomes white, right? And it might be useful to, let's do I still have my block? Hey, look at that. It might be useful to know that blocks have separate red, green, and blue attributes that you can access. And we could kind of quickly think about like what is the inverse of this color. And it might require some math operations too that you haven't seen yet. So let's work through that a little bit. Heck, we could write a function that inverts a color. So what is like the inverse of 32 in color space? Yeah, so it's 255 minus 32. So it's like flipping it around. So our color space goes from 0 to 255. And so we want to kind of flip all of these colors around the middle of that range. So if something was like right in the middle of that range at like 128-ish, like it wouldn't really change in an inversion, but things at the extremes change by a lot is kind of what happens. So if we do, if we just do 255 minus this number, like does that work for all cases? I just want to see what this looks like. That's plausibly the inverse of a nice purple. So we could say to invert the color of a block, you do block. I think is like a plausible inversion.
Should you use a bracket or parentheses?
What? Say that again?
The RGB equal to those three numbers should be in brackets?
Python, you mean like to group these?
No, the one before that should be a bracket, right? We want the total to assign to RGB.
Yeah, so these the parentheses here, so parentheses like do two jobs in Python, which is kind of fun. They group things. In this case, they group things into a tuple. In this case, they group things into an order of operations like you're used to from math. And parentheses also show up in calling things. So you have to kind of pay attention to the context of parentheses to figure out what's going to result. But because there are commas in here, this is going to turn into a tuple. So again, exercise 13 here. So now that we know how to convert a single, you might have to, I'm going to give you like a good 10 minutes for this, 5-10 minutes for this, because you'll have to create a new grid that has the same shape as the first one, and then fill it with the right colors that result in an inversion here. So I see some puzzled looks on people's faces. That's okay. I want you to dive in and like try some things. You're not gonna start a fire or like break any, your computer will survive any errors that occur in this process. You will survive any errors that occur in this process. So feel free to just try some stuff.
What is there must be a keyboard shortcut to switch something from a code cell to a markdown cell? Because I just did it by accident. I think somebody else earlier.
So Y switches it to a code cell. I think M switches it to a markdown cell.
Okay, so like escape M or something?
So if you do escape and Y, it'll turn it back into a code cell.
Okay.
Y. So Y is the keyboard shortcut to convert something to a code cell. Okay, I'm going to start to walk through how I would do this. First thing I want is a new grid that's the same size as the old one. It's width, height, yeah, okay. So I can use the input grid's width and height to make a new one of the same shape. And then So a tricky thing here is like looping over both of these. We can use range, right? Like we did before. So like for row in range grid.height, for col in range grid.width. I'll break it down a little bit. I know some, like here I was kind of doing everything on one line, and before, and I saw some of you all also trying to figure out like how short you could make this. That's fun. I'm gonna break it down a little bit and say like outgrid dot row col dot red equals grid row col dot red, and then the 255 minus, and then copy paste that, do green and blue. And then make sure I go back out 2 levels to get out of my for loop, and then return that other grid, the new grid. Pass in my grid. That's plausible. Black became white, at least. If we, first of all, like any questions about that? So I used a little bit of a new interface here that you hadn't seen yet. Instead of using the RGB attribute, I was directly getting the red, green, and blue values off of these, or assigning directly, using and assigning directly to red, green, and blue to split it up. Saw one person think like kind of had the kind of neat idea to do something like this. To say like, I want a new tuple that is the result of subtracting this from this. This doesn't work with Python's built-in types, but it does work with NumPy. So if this was a NumPy array and this was a NumPy array, this would work because NumPy is for maths and it understands like when we want to do the subtraction on 2 arrays, it means make a new array where the first element is the result of subtracting the first element of this array, or subtracting the first element of this array from the first element of this array, and so on. Python's built-in types are not math aware, so that doesn't work. There are some short ways you could do this though in Python too, with expressions. I kind of mentioned briefly that you can do like one-liner for loops. So I could do like 255 minus color for color. I don't know if I love in grid row col dot RGB. So I'm kind of doing like a one-line for loop here, where it'll loop over this. So this part looks the same as the loops we were doing before, but now we're only doing one thing with that loop variable. We're using it in this expression. And we put it in a tuple. So this is going to create a new tuple that is the result of evaluating this expression while looping over this. So another way of doing it on one line, if you were really hoping to do that.
Can you hold there for a second?
And I'm going to kind of delete that.
Can you type the top one again?
Oh, yeah. Okay. Sorry, it's really long and doesn't fit on my screen at this font size. I guess it does. Barely. Any kind of questions about functions in general here? Yeah.
So making that outgrid at the beginning is just so you don't replace the original one? Okay.
Yeah. Good, in my opinion, and this is only an opinion, but it's good hygiene not to change inputs to functions unless you explicitly tell your users that you are going to do that. Yeah, no, sorry, I can't get all of that on one row.
Can you clarify what we talked about earlier today about how when we, like when we make a copy of something, is that not happening here?
If you were to do, so I saw in your code that you had like outgrid equals grid. This would not create a copy. This would be operating on the same thing because
You defined it right above that line in your line. You defined something that just simply has the same dimensions.
Yep.
Okay.
Yeah. So this is a brand new one with the same dimensions.
Okay.
It sounds like there was also a copy method on grids that, hey, look at that. So this returns a new copy with the exact same colors, same size and colors, or like everything the same. So actually, that's there are other attributes of grids that we haven't talked about, but that this would have missed, like the fact that you can turn these lines off, or you can change the size of these blocks to be smaller or larger, and this would have missed all of that. So using grid.copy would be a better solution here because it would bring over the data identically. Michael mentioned that somebody tried this and forgot to put the parentheses at the end of this. That's something to watch out for. So we've kind of seen both attributes where you did access things like this, like the .rgb thing we've been using, or the .red and green and blue you see here. Some things attached to these variables are data, the attributes. Some things attached to these are functions. And copy is one of those. And if this is valid Python, you can do this. And what you get on this side is a reference to that function. You can assign like variables or you can assign functions to variables in Python. But what we really wanted to do was call that function and say execute the code inside there and then put the result over here. So we have to make sure we put the parentheses on here to make that happen.
So is there a limitation on the number of returns you can have?
So a return, do you mean like the number of things you can list here or the number of returns you can have on a function?
Like I'm putting in multiple things to do a return or multiple returns and it's only spitting out one thing.
Yeah, so returns, so you're doing something like this where you have like a return after in another part of the function.
Yeah.
So returns terminate the function. So as soon as you hit return, it goes back out to the code that called the function. It does not run anything after that. Yeah. There is a kind of a way to do that with the yield keyword that you can read about later, but it works a little bit differently. Question?
So creating a copy of the grid, if you make a change to that copy, it's not going to affect the original grid.
Right. So inside of this method, it's going to create a new grid with the same properties as the original grid, and make sure it has all the same colors, and then return that so that these are completely different. They would look exactly the same, but be completely different things in memory in Python.
So what was it you just said again, the last sentence?
Yeah, so I don't have a great way to explain this, but I was saying like they're different grids in memory. So Python has like you can kind of think of like inside your computer in the memory, there is some space allocated to storing the state of your grid, right? And if I do outgrid equals grid, no new memory gets devoted to holding information about your grid. What you end up with is two names that point to the same grid in your computer's memory. But when I do .copy, all of that data gets copied, literally copied, in your inside your computer, so that there's one chunk of memory associated to storing data about one of the grids, and a whole nother set of memory devoted to holding information about the other grid. And they are different. And when you do operations on one, it has no effect on the other because they're different things in Python.
Is there a reason, I hesitate to use justification, but is there a reason why Python does this? Like, for example, in MATLAB, if you say x equals y, x just is a numerical copy of y. It doesn't affect y in any way. You can multiply x by 0, it doesn't affect y. But what is the reason why the authors or architects of Python wanted outgrid equals grid to be just pointing at the same location?
Efficiency, copying things. It's like it's not, it would be safe to copy things, like safer to copy things every time you did a new assignment, but it's inefficient. Like you have to go allocate new space for all of that stuff and make new pointers to all of it. And like, how deep do you go? Like if you have a list that contains lists, that contains dictionaries, like how, do you go make a copy of every single one of those things? Since not every application of like assigning new variables to things requires making a copy, the default in Python is to not, because it's more efficient, but there are capabilities for doing so fairly easily. For example, one of the standard library modules is called copy, and it has functions that help you make copies of things if it's necessary for you to do that in your application.
Yeah. So, and interestingly in MATLAB, so at least for passing like arrays into functions in MATLAB, they actually pass in, so Matt's not using the word, but a reference to the array, right? Unless in the code you change one of the values in the array, in which case MATLAB detects that and makes a copy inside the function of that array and then changes that. Okay. Python doesn't try to be anything as smart like that. So it's, I mean, and it's a little bit of a sneaky thing for MATLAB to do, and but I guess it must be reasonably efficient because, you know, the code executes pretty well, pretty quickly. So, but yeah, there are other languages that do this. They just sort of hide it from you.
Yeah. And even here, we can see the words like deep and shallow in copy, right? So it's probably getting to what you're saying about how much of an image you're taking.
Yeah. So like a shallow copy only makes a new. Like if you do a shallow copy on a list, it makes a new list that's still pointing at the same variables, but it's a different list. And then a deep copy will actually try to like go for every thing in that list, also make a copy of it so that they're like wholly independent.
So then with the shallow copy, if you were to change data in the first list that the shallow copy referred to, that would then also change the data in the shallow copy.
Yeah. Yeah, so if you make a shallow copy of like a list of lists, you still could, and then change one of the value of the lists inside the list, like that would still be reflected in both of those.
So is the dot copy here a shallow copy or a deep copy?
For us, this is a deep copy, like because it returns a completely new set of a completely new grid with new blocks in it.
Is that, how do you know if something is, if you copy something as a shallow copy or a deep copy? Like, does this function always do deep copies?
This always does deep copies. You have to read the documentation. Okay. The last thing I wanted to do, which I think I will maybe demonstrate instead of having you work on it, since I want to leave some time at the end. We're going to end at noon. I want to make sure we have some time to kind of give you a little bit of an overview of like the scientific Python ecosystem, and then take any questions. Like if you're like, I do this thingy, like what parts of the scientific Python ecosystem are going to be most interesting to me, I can try to answer those questions. I can't make promises. But I did want to, but kind of before we get into that, I did want to show a little bit more of the lists and dictionaries we keep talking about, and another useful Python data type, strings. So let me kind of get into that. So you've seen tuples, you've seen lists a little bit. So this is a tuple with the parentheses, and a list looks pretty much the same but has square brackets instead of parentheses. But these are both ordered sequences. You get things out of them using numbers, zero-based sequences, kind of in the same way we did with the grids. The key difference between tuples and lists is that tuples are immutable. I cannot make a change to a tuple. Lists, I can change to my heart's content. Both lists and tuples can contain anything. Like these are not arrays. If you've worked in like a numeric language where you're like, this is an array of integers and you can only put integers in it. Lists and tuples and dictionaries don't work like that. You can put anything in them. Even other lists or other tuples or dictionaries or grids. You could have a list of grids, anything you want. Strings, you put in quotes. They can be single or double quotes. I like single quotes because I don't have to press shift in order to write them. But if you, it can occasionally be useful to use double quotes if you are writing something that has single quotes inside of it, in this case. Something to note about strings is that they work a lot like sequences. So I can pull parts of a string out. I can slice strings. You end up using strings a lot, especially if you're reading files, like writing file reading code, because Python is not interpreting the contents of your file. It's giving you strings, interpreting it as text, and it's like up to you to decide if you need to convert something to an integer or a float. So you'll work with strings a lot, even though we didn't introduce them here. Kind of the exercise, yeah, question?
Do you have to have escape characters in strings?
To escape?
Like if you've got, say you've got a string that contains both single and double quotes, how would you,
yeah.
In like SQL you've got escape characters.
Yep. So I think the backslash is the escape character. Yeah. Oops. Yeah. So backslash if you need to escape something.
The other thing to note is that you can't assign to strings.
Strings are immutable, which is actually pretty handy because you can like safely pass them around and know that nothing will ever change them. But yeah, you cannot do something like this. Again, no changing that. Python has oodles of facilities for working with strings, especially some really slick string formatting options. So if you need to, print some numbers in a particular pretty format, like Python's got you covered. You can go read about that. I think we linked to it in our README. A whole bunch of information about that. They also have a lot of methods. So like if you're doing something where you're like, I want to convert uppercase, lowercase, or I want to replace all of this character with this other character, that's all there. Dictionaries are what's called a mapping, where you kind of associate one thing with another thing. Often strings are the like you kind of give something a name as a string, and then on the other side you have whatever it is. You use curly braces for this. And the colon, so this is an association. Like we're associating the string capital A with the number 1. And then we're going to use the square brackets again for getting things out. But we're using names instead of positions. We can also put new things into the dictionary. Or change the value of things that are already in the dictionary. You can remove things from a dictionary if you so desire. Okay. To kind of put this together, I'm going to make a function that will follow a path in a grid from like a starting point, changing the color as it goes. And I want to be able to define the path as a list of directions, like go right, down, left, up, so on. But I need to be able to translate that into coordinates in the grid, indices in the grid. So I'm going to make a little mapping here of a dictionary. You'll notice I'm doing a new line here so I don't get things like spilling off the right side of my screen. Inside of things like lists and tuples and function calls and dictionaries, like you can put in new lines and they don't end the line. So like going up means reducing the row index by 1 and not doing anything to the column index. Down is the inverse. Right is increasing the column index, and left is decreasing the column index. Cool. And then if we have a path, we can say like the current position equals the starting point, and then for direction in path, I'm going to say the grid position, I'm actually going to see if this works, equals color. And then we're going to update to the next position in the list, which will be like position equals the first element plus direction, or let's see, move equals directions, direction. And we don't need to return anything from this function because we're changing the grid that as it came in. We're not making a copy. We could make a copy and return that instead. So let's see if this works. Actually, it's going to make my life a little bit easier if I make a copy. And then we can do path, color, grid, and do like down, down, right, down, and start from say 1, 1, and make it nice aqua. Okay, so that worked. So list, a nice ordered sequence of things, a tuple, again, an ordered sequence of things. I could have used a tuple here too. It wouldn't have mattered because none of this isn't being changed. You can pick and choose which one you want to use. Like, I guess tuples are a little safer because you can't accidentally change them, but I mostly see people use lists and not tuples. I think the square brackets just kind of call out that it's a sequence a little bit more than the parentheses do. But functionally, in a lot of cases, they would be the same. And then using the mapping here to say, like, to map a semantic name to like a movement. So that we don't have to, so that our users of this function don't have to like remember all of this. They can just say go down, down, left, right, up.
If you're down, down, right, down.
You're right. I think it's because I'm doing this update after changing the color. So I think what we should do is, so it's getting to the last item and updating the second, doing the second to last one, and then doing this. I think what we should do is change the starting point like right off the bat, and then change this after we do the update. Because the trick is we actually want to change more. We want to change one more block than is in this path. So when we were looping over this path, we would do 4 moves, but we actually wanted to change 5 blocks because it includes the starting point, and this path doesn't include the starting point. So that would hopefully get that right. So any questions about like lists, dictionaries? I know I haven't done much more than make you aware of their existence.
Renaming to the same variable.
Mm-hmm.
I mean, you've got grid equals grid.copy. So
Yep.
does that renaming stay purely within the function, or okay?
Yeah. So any variables you create here inside the function stay inside the function and are not accessible from outside the function. Good question. And one more thing we didn't get to was reading and writing files. So another good thing to research when you have a chance on your own. Okay, so we got about 20 minutes left. I wanted to give kind of a brief overview of what's out there. Whoa, that was wild. Okay. In terms of like the scientific Python ecosystem, it is massive. There is just tons of stuff out there that can get very domain specific. At the core of it all is NumPy. How many of you are taking the NumPy tutorial this afternoon? Almost all of you, awesome. NumPy doesn't kind of have a lot of, it doesn't have a big feature set. What it has is arrays that are implemented in a low-level language, C, and that can do operations like on those arrays of numbers at C speeds, very fast. Python Python does a lot of operations as it works, and especially in loops, that adds up to a lot of overhead because it's checking things like, are you indexing outside of an array? And kind of doing a lot of keeping track of things so that when there's an error, it can show you like a big list of where you were and when that error happened. C doesn't do a lot of those nice things by default. It just kind of runs blazing fast through whatever you tell it to do, which is nice because it's fast, but then when things go wrong, you have almost no clues about what went wrong. It's a lot of fun to debug problems in C. So NumPy kind of tries to give you the best of both worlds by giving you an interface that's written in Python where they can kind of check some stuff before it goes down into the C level, but then when they need to run a bunch of loops because you're trying to do an operation on millions of numbers, it goes and runs in C and is super fast. Depending on what kind of field you work in, you may not actually end up using NumPy directly very often. A lot of fields, for example, use pandas instead as their main data interface. Pandas is built on NumPy, so like under the hood, a lot of operations in pandas end up using NumPy, but you're not kind of directly working with NumPy, and that's true for a lot of things. For a lot of operations you end up doing, you kind of like get an array through some other library and don't even care that much that it's an array, but then you pass it off to something else, and it cares that it's an array and like uses that interface to do stuff for you. So even if you don't end up using NumPy directly, it's kind of it'll been worthwhile to like go to that tutorial and learn about the basics of it, so that because it gets referenced a lot and used a lot in other libraries. There are a number of plotting libraries in Python. Matplotlib is the main one for making figures for like publication. Or kind of images. It kind of depends what you want to do. A lot of people want to do data visualization on the web now, like in browsers. Matplotlib is not great at that, especially if you want interactivity. Because its kind of specialty is like making high quality output graphics like PDFs. Other options for like making web native things are like Bokeh, Altair now, Plotly. There's a few. Those are the main ones, I think. And then Matplotlib actually has other libraries on top of it. For example, Seaborn, that provide a kind of a different plotting interface and different sets of defaults and different plots on top of Matplotlib. I mentioned pandas. They don't have it listed on this page. Pandas is really useful when you're working with tabular data. For example, a CSV file that has like rows and columns, and especially when the columns have like a label associated with them, like some kind of identifier, because pandas lets you do grab labeled data kind of very quickly and transform it. So a lot of like spreadsheet operations, a lot of SQL operations, if you use SQL, are possible in pandas. I, for a long time, did not use pandas because I worked in astronomy. And astronomers work with images, which are just like arrays of numbers. And I was working with people who are actually kind of implementing a tiny subset of pandas called tables that where they like, you would ultimately kind of end up with like a bunch of data that was in a table, but like they wanted a tiny subset of the functionality that's in pandas. so I wasn't really using it. But then I got a job where they were using pandas all the time because they were working with these data where there was like a bunch of columns and a bunch of labeled rows, and they would want to do things like join them, like do a SQL like join in Python. Pandas has that. So pandas is super popular. You see it all the time. I assume a lot of you are doing the pandas tutorial tomorrow. Nice. Also matplotlib. How many of you are doing the matplotlib tutorials tomorrow? Good chunk. Yeah, you're getting very good base there. SciPy is another one of these kind of foundational libraries that, depending on your field, you may not end up using directly all that much. It's full of algorithms. So a lot of kind of numerical work, whether it's like statistical modeling or like kind of machine learning or kind of anything, depends on optimization, like doing minimization routines. SciPy like packages up all of that old stuff, even like Fortran, like ancient Fortran routines for doing minimization and stuff get packaged up in SciPy. And then a lot of other libraries like scikit-learn, pandas for some things, any other kind of library where they need to do like a fitting or an optimization usually ends up depending on SciPy because like those core algorithms are there, even though they're putting a different interface on top of it. There's linear algebra, some statistics, though there are other libraries for doing statistics too. Some image signal processing, numerical integration stuff if you have to do that kind of thing. But pretty low level. So like a lot of times other libraries are built on top of this to do like domain specific things. Like I said, I worked in astronomy. There's an AstroPy library if you were that contains a lot of that. And like just depending on your field, there is almost certainly like a library or more than one library devoted to like doing that stuff. And so you'll need to Google for like your field plus Python and like see what you find. Any like kind of specific questions about like just like anything? You're like, I want to do this. Like, what's out there?
I have a question, but could you put your Jupyter Notebook back up?
Oh yeah.
Thank you.
Michael, do you have a favorite scientific Python library?
I work with seismologists, and so it turns out there's a seismological data processing package called SciPy that builds heavily on a lot of the stuff in SciPy, so the signal processing stuff, and we use that all the time. And it's replaced a whole bunch of really cheesy older packages.
You look like you have a question.
I guess in terms of spreadsheet data, so I started an emergency department physical therapy program at my hospital in Colorado Springs, the busiest emergency department in the state of Colorado, 3 years ago. And I have all of this data, and in grad school I used SPSS, which was terrible for my project because I had a lot of string data. And I was curious, it sounds like at Clover you're dealing with the same kind of, healthcare related patient information. I'm getting a lot of pushback about what does this open source mean? Does this mean you're doing something with patient data unethically? So I guess just advice on talking to IT and information security people about that, because they're afraid. I think none of them know what I'm talking about when I say I'm going to a SciPy conference, but just for healthcare data.
Yeah.
Well, I mean, you need to distinguish between open source software and open source data.
Right.
So that's the first thing you need to explain is that, I mean, and lots of IT departments are freaked out by open source code, just in general. And that's a hard battle.
Yeah. At this point, there are, one of the easiest things to point to is maybe like the vast number of places that are already using Python in sensitive environments. ours, like in health insurance, it's huge in finance. Tons of finance companies are and banks are using Python, and especially numerical Python for doing machine learning and analysis. Like, there's a bunch of people here from Bloomberg. There's people from Capital One. Has a big Python contingent. So
That's a great idea.
Like-
Well, have you heard of Clover? Have you heard of, and many of our IT and IS people are gonna say, oh, yeah. I can say, well, I went to a and this is
Yeah.
all about Python, and they use it safely, and they protect patient information just fine. But I think that's a good approach too.
Yeah, and then there's like the question of the like execution environment where the code runs.
Yeah.
That's kind of the big thing that we have to tick off. Is like, where is this running and who has access to it? And so if you can answer that question, you can work with your people to see if they're satisfied with that.
So I worked in healthcare for about 8 years, and I worked in consulting for pharmaceutical and biotech companies, and a lot of consulting firms that handle pharmaceutical data are moving toward more like open source tools and modeling. And I would actually argue, because I worked at an old school insurance company, that the environments within which you are storing your protected health information are more dangerous than something like Python. So if we had non-de-identified data sets in tables, and anyone who had access to it could pull all the information out, and like most people don't realize how, if you've ever had a claim paid by someone not you, and like were employed and have insurance, your data is in like a ton of different databases, and a lot of them are running like really old Windows stuff. So when you look at things like hospitals getting targeted with ransomware, like it's so much easier to get that data out that way, like than using like a big
That's
ecosystem.
another excellent point.
If I could chime in, just something to be aware of is something that they might really be concerned with is that, let's say you're, using something like SaaS, like a lot of healthcare industry and medical device and that sort of thing use. One of the big differences between using an open source tool and using like software as a service like SPSS or SaaS or what have you, is that if there's some sort of glitch or a problem, you cannot then go back to the manufacturer and say, help us, or we got a big problem with a client or customers or whatever, because it is an open source tool. So that puts a greater concern in terms of liability with your organization. If you had a glitch with SaaS, they're going to be there because you're paying for it, you have a contract and agreement, what have you. So that would be a big area of concern and a difference. Just
Have
something to be
you-
aware of.
Have you dealt with SaaS support?
I'm not endorsing one or another. I'm just trying the distinction, for organizations that could be a concern. I've worked both in the private sector and for the federal and state government. So I make no judgments about service or the lack thereof or anybody's product or code or anything.
I would sooner turn to open source.
Yeah, I'm a big open source proponent myself,
A big chunk of our job is go out and Google it in the first place anyway.
when in danger, when in doubt, when in circle, scream and shout, Google it.
Now, can we make a Python into an executable code only? This way nobody can change once it's verified, and then that version is the version stays there forever. Can you make it executable? And then-
Yeah, I've never had to do that. There are things for like packaging things up into like a kind of like one tarball, like so that you can then like hash and like have an identifier associated with. People nowadays, like I think this happens a lot more at the execution level. So people are using like containerization systems like Docker, where they can say like code, like I deployed this Docker image, which has a specific identifier, and I know what went into that. And like I can say like that Docker image is what's running on this computer and associate like a deployment with a specific set of code, and not even only code, but an entire execution environment is another way of going at that. So even if you package up Python, or like even if you package up Python into an executable, there's a whole bunch of other stuff that goes on around that in the execution environment that's like part of your audit trail too. So there's different ways to approach that, especially now that like containers, like Docker and containers are a thing.
And that's part of at least, I started the project before as like we had a major shift in how we deal with research related data. And so before I just had, a giant SharePoint that I could pull off whatever I wanted all the time. But now it's something called RedCap. And I can't remember if it's Vanderbilt or one of them. But there's certain columns that they've made so you cannot export them, which is a good, I think, way of answering that. And there's probably better in many ways, but it's really slowed things down because now there's one group for the entire University of Colorado that is spitting out the reports of my data to deal with. And so it's like, it's trade-offs.
But I mean, again, you need to draw the distinction between the data that you're dealing with and the code that you're using. I mean, you could, if you have non-anonymized data or non-de-anonymized data, you could hand that to somebody with a spreadsheet, and that's just as dangerous if you hand it to them with say, Python or SAS or anything else, right?
Yeah,
so the data is the problem, not the code.
Yeah.
So when you said that it comes down to where you run the code, are you talking about like it being in a production environment versus a development environment?
Or, yeah, more to the point around like access control. When stuff is running here, and then like Michael's saying, it's really the data that you're worried about usually. Well, I mean, code can be proprietary too, but for regulatory purposes, it's usually the data. It's like who has access to that data. So when you have data in a database, like who has access to that? And on a computer too, like if you can get access to a computer, you can like watch what's running there, watch what's flowing over the wires, and like look at the memory and stuff. So it's like who has access to that computer, and are we monitoring what they do there, and stuff like that. So usually like at Clover, we have several different environments where we have a production environment where we have obviously protected health information, because it's what we do. We also have staging test environments where we also have PHI in order to test things on realistic data. We also have non-PHI test environments that have fake data so that we can like share that more broadly with people. Because like if we want to show somebody real data, like we can't. Unless they're like internal. So we have like special, when we want to show external people like how our stuff works, we might have to set up a fake thing to show them so that they, the legal stuff works out. But then you can have different levels of control or different levels of access for those different environments if you've set up your systems in the right way.
Also, you might write different code if you're in different environments. If you're talking about like command line tools that you're going to give to somebody, you might write that code differently than if it's code that's being called by a web server somehow, where all of a sudden the code and the data that's accessing are much more vulnerable.
Yeah, there's a question here.
I was just asking, you're talking about your environment, so has your company ever looked at differences of whether you should use OpenShift or say Anaconda Enterprise?
Yeah, I've looked at it a little bit. It hasn't been something that's like ended up being sensible for us. Like I've looked at Anaconda Enterprise, for example, and we were like kind of too small of a company for it to make financial sense for us. But it looks very useful. There are also like hosted things like Google has products like Cloud Data Lab, which are like notebooks that run on Google. If you're doing machine learning, Amazon has a whole suite of machine learning things that like where they have hosted notebooks and stuff. Did you have like a specific question about those things?
So if you're going to use like OpenShift, like what we did is Jupyter Notebooks, actually create Jupyter Hub and then spin off Jupyter Notebooks.
Mhm.
We could get our clients to go ahead and just, from across country, take a look at our code. And I'm looking at that and I'm going, well, why should you go to Anaconda where you can basically create anything that you need within an OpenShift environment as long as you have the code that you're using? I was just wondering if you had any experience with that.
Not that I've ever actually set up. I know like kind of Anaconda is like very enterprisey where they're like, we'll give you auditing tools, we'll give you like logging, we'll do accounts management and
Right, but you can do that within OpenShift, so I'm trying to find.
okay, I don't know anything about OpenShift. Yeah, I can't compare to OpenShift.
Okay, I was just curious.
I've only compared like Jupyter Hub, like the open source project, to like Anaconda Enterprise. Yeah, and there was another question.
So the same way you select a block in like an array, or since, like, for this instance, the grid, you can iterate that over like a real data table with actual data. Can you select a block to point to another data table or another function or other information?
Not sure.
Table in Java.
Not sure I totally understand that question.
Like a hash table, you can't have a block that you select in a grid point to another set of information.
Okay, so grids might be a bad example of this because they're homogeneous, or like our grids are homogeneous, kind of like NumPy arrays. Like, but in Python, things like Python lists or dictionaries, you can change them to point to any arbitrary thing.
So you could do that with like a table though as well.
Yeah, it would depend on the underlying implementation of like the thing you were using. NumPy actually has an array type that like can contain anything, but it's basically a list. Anyway, we're done. This is my contact info. Feel free to get in touch with me if you have more questions later. Thanks for coming, and I hope you enjoy SciPy.